Good day, everyone. I am Cristina Generalao, and I am your teacher for today's discussion.
Equation. What is a quadratic equation? A quadratic equation is in the form of ax squared plus bx plus c equals 0, where a, b, and c can have any value except that a can't be 0, and x is the variable or unknown since we don't. Finding roots of a quadratic equation. There are three ways to find the solutions or roots of the function. First, we can factor the quadratic equation. Second, we can complete the square. Or third, we can use the special quadratic formula, which is x is equals to negative b positive negative square root of b squared minus 4ac all over 2a. Factoring quadratic equation. There are steps in factoring a quadratic equation. First, get the product of a and c and copy b. Second, rewrite the middle term with those numbers in step 1. Step 3, factor the first two and last two terms separately. Step 4, if we've done this correctly, our two new terms should have a clearly visible common factor. Examples. First, factor x squared minus 3x minus 4 is equals 0, and its coefficients are a equals 1, b equals negative 3, and c is equals negative 4. Here's the solution. For step 1, we're told to get the product of AC and copy the value of B. So, AC is equals to negative 4 since A is equals to 1 and C is equals to negative 4 and B is equals to negative 3. Step 2, we need to write the second term, which is negative 3x, using the numbers in step 1. So, it must be x and negative 4x. So, for the step 2, we have x squared plus x minus 4x minus 4 is equals 0. Step 3, we need to factor the first two terms and the last two terms separately. So, x squared plus x has the factor of x times the quantity of x plus 1, and negative 4x minus 4 has the factor of negative 4 times the quantity of x plus 1. So, for the step 4, we have x plus 1 as common to both terms. Thus, x plus 1 and x minus 4 are the factors. To check if we are right, we just simply multiply x plus 1 and x minus 4. So, x times the quantity of x plus 1 minus 4 times the quantity of x plus 1 is equals to x squared plus x minus 4x minus 4. And thus, it is equal to x squared minus 3x minus 4.
Example is 2x squared plus 7x plus 3 is equals 0. Since that our goal is to have 3 coefficients and 2x squared as the first term, we must factor it out as 2x plus 1 times x plus 3, because 2x times x will give us a factor of product of 2x squared, and 2x plus 3 will give us 6x, and this is x, and this is 3. So, we have 2x squared plus 6x plus 7x rather plus 3 is equals 0. But we must equate our roots to 0, and it must be 2x plus 1 is equals 0 and x plus 3 1/2. That will be our first root. Our second root is x plus 2 equals 0. Copy x and transfer 3 to the right side becomes negative 3. And our second x will be x plus negative 3. So, 2x squared plus 7x plus 3 equals 0 has roots of its roots. X is equals negative 1/2 and x is equals negative 3. And so we're done.
The second way to find the roots of a quadratic equation is by completing the square. And completing the square, we're going to take the quadratic equation ax squared plus bx plus c and turn it into a times the quantity of x plus d squared plus e equals 0, where d is the quotient of b and 2 squared and e is equals to c minus d. Then, the roots are in the form of quantity of x plus d squared plus e. There are 5 steps in completing the square. Step 1. Divide all terms by a. Step 2. Move the number term c over a to the right side of the equation. Step 3. Complete the square on the left side of the equation and balance this by adding the same value to the right side of the equation. Step 4. Take the square root on both sides of the equation. And step 5, subtract the number that remains on the left side of the equation to find x. For example, complete the square of the following equations. First, x squared plus 6x plus 7 equals 0, where a is equals 1, b is equals 6, and c is equals 7. So for the solution, we must transform x squared plus 6x plus 7 into quantity of x plus d squared plus e. But we must find the value of d and e first. So, since d is equals to b over 2 squared, our d must be 6 over 2 squared. And 6 over 2 is 3, and 3 squared is equals to 9. So, d is equals to 9. And for the value of e is equals to c minus d. Since that our c is 7 and our d is 9, so a must be 7 minus 9. So the value of our e must be negative 2. Now, we're going to substitute the value of d and e for us to complete the square. So, quantity of x plus 3, which is the value of our d squared, minus 2, which is the value of our e, is equals 0. Thus, x squared plus 6x plus 7 is equals to quantity of x plus 3 squared minus 2.
Example is 5x squared plus 4x minus 2 is equals 0. Since that we have 5 as a coefficient in the first term, we must divide all the terms by 5 so that we'll have this as a one term, or we don't have a coefficient for the first term. So divide by 5, divide by 5, divide by 5, divide by 5. Then, x squared plus 4 divided 5 is equals 0.8. So 0.8x minus 2 divided by 5 is equals to 0.4 is equals to 0. And that, it is easy for us to find its roots. But we're going to complete the square to have its roots. So we must find the third term. And it must be x squared plus 0.8x plus the third term is equals to, transferring 4 to the right side becomes 4.4 minus the third term. But to get the third term, we must divide our and is equals to 0.4 minus 0.16. And that we need to factor this out. In factoring this out, we have x plus the square root of 16, which is 0.4, and squared. So it is equals now to negative 12. Therefore, 5x squared plus 8 plus 4x minus 2 is just equals to x plus 0.4 squared minus 12. And we're done.
Third way to find the root of a quadratic equation is by using the quadratic formula. A quadratic formula is x is equals to negative b, positive and negative, square root of b squared minus 4ac over 2a, where square root of b squared minus 4ac is called the discriminant. Note that when the discriminant is positive, we get two real solutions. When the discriminant is 0, we get just one real solution. And when it is negative, we get two complex solutions. For examples, find the roots of the equations by using a quadratic formula. First, solve 5x squared plus 6x plus 1 equals 0, where a is equals 1, b is equals 6, and c is equals 1. Solution. Using the quadratic formula, x equals to negative b, positive and negative square root of b squared minus 4ac all over 2a, we just simply substitute the value of a, b, and c. So x is equals negative 6 as the value of b, positive negative 6 squared minus 4 times 5 times 1 as the value of our b, a, and c, all over 2 times 5 as 5 as the value of a. So x is equals to negative 6, positive and negative square root of 36 minus 20 all over 10. Then x is equals to negative 6, positive and negative square root of 16 all over 10. Then x is equals to negative 6, positive and negative 4 all over 10. Thus, x is equals to negative 2 or x is equals to negative 1.
Our second example is negative 3 if
Third example, solve 5x squared plus 2x plus 1 using quadratic formula where a is equals 5, b is equals 2, and c is equals 1. Solution. X is equals to negative b, positive and negative square root of b squared minus 4ac all over 2a. So we must simply substitute the value of a, b, and c. It must be x is equals to negative 2, positive and negative square root of 2 squared minus 4 times 5 minus 1 all over 2 times 5. So, x is equals to negative 2, positive and negative square root of 4 over 20 all over 10. Then, it implies that x is equals to negative 2, positive and negative square root of negative 16 over 10. Note that our determinant is negative, so it must have an imaginary root. Therefore, x is equals to negative 2, positive and negative 4i over 10. Thus, x is equals to negative 0.2, positive and negative 0.4i.